So factorial notation and a key word, permutations. So it says this. Consider how many different ways there are of arranging 6 different books side by side on a shelf. I'm so glad Darian asked me that question because it was a great segue. Using the fundamental counting principle, we got that. We drew 6 blanks and we said that you got pick 6, then 5, then 4, then 3, you awake, then 2, then 1. Okay, you're going to notice a lot of the time in your homework, you'll be going 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That would be the number of different ways to rearrange 10 people. Or if I wanted to do 30 people, 30 times 29 times 28 times 27 times, there's got to be a shorter way to write it. And there is. 6 times 5 times 4 times 3 times 2 times 1 is denoted by 6 exclamation point. That is not read as 6. That is read as 6 factorial in math. And it means take that number, times 1 less, times 1 less, times 1 less, and stop when you get to 1. Without using a calculator, what would 4 factorial be? 4 times 3 times 2 times 1. In your head, please. 24. Without using a, by the way, I will show you where this is built into your calculator, but it's such a pain, sometimes it's easier to do the smaller numbers in your head because it's really not that much quicker on your calculator. What would 3 factorial times 2 factorial be? Well, that would be 3 times 2 times 1 times 2 times 1. In your head, please. I think it's 6 times 2? 12. Also, I want you to notice that 6 factorial can be written in a variety of ways. If you write it out all the way, 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. But 2 times 1 is actually 2 factorial. You could write it as 6 times 5 times 4 times 3 times 2 factorial. Or, you know what? 3 times 2 times 1 is really 3 factorial. You could write it as 6 times 5 times 4 times 3 factorial. Or you could write it as 6 times 5 factorial because 5 factorial, Brendan, is 5 times 4 times 3 times 2 times 1. So there's different ways to write this, and some are more convenient than others. But as a shortcut, factorial notation, Karn, pretty good. You got an attention span? You here? Okay. That trick can allow us to simplify certain quotients. For example, if you want me to go 6 factorial over 4 factorial, I can recognize, first of all, which one's bigger, 6 factorial or 4 factorial? I rewrite the smaller one, and I start to expand the bigger one. 6 times 5 times, and I'm going to write 4 factorial instead of 4 times 3 times 2 times 1. Why did I stop there? What do I have on the bottom of my fraction? Why did I stop with a 4 factorial on the top of my fraction? Because it turns out, in fact, do you know what 6 factorial divided by 4 factorial is? You can now do it in your head. 30. 30. 25. 30. 35. 30. Right? Right? 30. I know it says 30, but still walking you through it. In other words, Mr. Dueck, ready? What would 101 factorial divided by 99 factorial be? Which one's bigger? I would say, you know what? Leave the 99 factorial. This is going to be 101 times 100 times 90. Ooh, I'm going to stop breaking it down there. Instead, I'm going to represent the rest of it with 99 factorial. What's 99 factorial divided by 99 factorial? Cancels. What's 101 times 100? You know what? When you multiply it by 100, what do you really just do? Add what? 2 zeros. This is going to be... It's faster, Logan, to do that in your head, then write it. In fact, your calculator can't do that. I'll show you where the factorial button is in a second. Okay. Express, it says, 5 factorial as a product in 4 different ways. Well, the long way is 5 times 4 times 3 times 2 times 1. It's also 5 times 4 factorial. It's also 5 times 4 times 3 factorial. It's also 5 times 4 times 3 times 2, whatever. I'm not going to do all of them. But I want you to realize that when you see the exclamation point, Sterling, what you're seeing is a long descending multiplication equation. And you can stop wherever you want and replace the rest with factorials. This. So C says, complete the following. 12 factorial equals what times 11 factorial? Yeah, Ty. 12. 8 factorial is the same as what times 6 factorial? Matt. There you go. Because 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. D says, express as the quotient of factorials. Say what quotient mean? Oh, you know what? It wants me to write 6 times 5 times 4 as something divided by something. I'm going to give you a hint. What would I divide by so that I only have 6 times 5 times 4? How would I get rid of the 3 times 2 times 1? 6 factorial divided by 3 factorial. The 3, the 2, and the 1 would cancel. The 6, 5, 4 is left behind. Seeing it? Seeing it? Another way to write 15 times 14 times 13 times 12 is 15 factorial over. I want to cancel the 11, the 10, the 9, the 8, the 7. And we're going to have to sometimes use this because it turns out factorials get so big so fast, your calculator can only go up to 70 factorial before crashing. So that one that I did with you earlier with the 101 factorial, your calculator can't handle it. It'll crash. So, I like E, I like E, I like E.
Is it going to be the test?
Might be. It says, without using a calculator, simplify that. Okay. What's bigger, the top or the bottom? What's bigger, the top or the bottom? That's the one I'm going to start to expand. And it's going to be, Brandon, what did you say? 10 times. So, and what will happen to the 7 factorials is? So I'm just going to write that. Did you hear him? He said it's going to be times 7 factorial divided by 7 factorial. Really, that is 10 times 9 times 8. And I can do that in my head. What's 9 times 8 in your head?
72.
Times 10. Is that okay, Jordan?
Yeah.
Next one, a little tougher. 8 factorial over 5 factorial, 3 factorial. Okay. This one I'm going to write out a little bit. First of all, what is the biggest number in this, the 8 on the top? So I'm going to go like this. 8 times 7 times 6 times 5, and I'm going to stop there. What am I going to write instead? And I got a 5 factorial, and I got a 3 factorial. I can certainly do this. What's 3 factorial? What's 3 times 2 times 1 in your head? So this here is really a 6, which means, hey, is there a 6 hidden on the top? Now, by the way, why can I cancel? Because when you're multiplying, you can cancel. If you're adding stuff in fractions, you can't cancel. But if you're multiplying, you can cancel. I end up with what 2 numbers left behind? 8 times 7. What is 8 times 7 or 7 times 8? Turn the page. As an algebraic definition, Logan, we say this. N factorial is defined as n times 1 less times 1 less times 1 less. Keep going, and you'll always end with 3 times 2 times 1. That's the formal definition of factorial, if you wanted to write it out algebraically. So 6 factorial would be 6 times 5, 1 less, times 4, 1 less than 1 less, times 3, times 2, times 1. A million factorial works for this as well. Oh, where n has to be whole numbers, unfortunately, there's no such thing as 6.3 factorial. Because you'd go 6.3 times 5.3 times 4.3 times 3.3 times 2.3 times 1.3 times 0.3 times, you never get to the actual 1 and you never know when to stop. Okay. N factorial can be written, 0 factorial is defined as 1. That doesn't make sense, I realize, but it has to be that way. Otherwise, we end up with a bunch of other problems. And so I'll talk about later on why 0 factorial is 1. Where do we show? Oh, there it is. We will get into it on a calculator. Okay. N factorial, this can be written as a number of ways. N factorial is n times n minus 1 factorial, or it's n times n minus 1 times n minus 2 factorial, or it's n times n minus 1 times n minus 2 times n minus 3 factorial, or I can replace the n minus 3 factorial with n minus 3, n minus 4 factorial, or I can break it down as far as I want. Big deal. Actually, great shortcut. Let's do some examples. First of all, it says complete the following. So we're going to do some algebra here. N factorial is the same as what times n minus 1 factorial? That's part of the definition. Okay. N plus 2 factorial is equal to what times n factorial? Well, first of all, would be that. The same way, if I had 7 factorial, the first thing I would write, Brendan, was a 7. The same way, if I had 12 factorial, the first thing I would write was a 12. And then I go down by 1. What's 1 less than n plus 2? Ah, Dom, what? What's 1 less than n plus 1? N fact. Oh, you know what? There it is right there. Another way to write n plus 2 factorial is n plus 2 times n plus 1 times n factorial. Or n plus 2 times n plus 1 times n minus 1 times n minus 2 times, I could keep going. N minus 4 times n minus 5 times n minus 6 times ... times 3 times 2 times 1. What factorial is that? Oh, they're thinking now. Is this 1 smaller than 8? Is this 1 smaller than 7? Is this 1 smaller than 6? Is n minus 5 1 less than n minus 4? Is n minus 6 1 less than n minus 5? Any thoughts? No, how do I understand you?
What about the 3, 2, and 1?
It always ends in 3, 2, and 1 because eventually you got to come to a stop multiplying. So don't worry about that. Focus on this. You guys are way overcomplicating it. Brandon, what? Don't believe me? If you were to expand this, you would start with n minus 4. What's 1 less than n minus 4? Not n minus 3. What's 1 less than n minus 4? N minus 5. What's 1 less than that? N minus 6. And you would keep going. When would you stop? When you get to 3 times 2 times? It's the definition of factorial. I like example 2. I like example 2. I like example 2.
Number 2. Is example number 2 going to be on the test?
Probably. I'm going to give you on the test some algebraic factorials to simplify. You ready? A says simplify this. You ready? What's bigger, n plus 2 or n? Think about it. And this is why when we were doing numbers, I kept saying, hey, which is the bigger number? What's bigger, n plus 2 or n? N plus 2. That's the one that I'm going to expand. So you ready? I'm going to rewrite the n factorial that's on the bottom because it's the smaller one. And I'm going to start to break down the n plus 2. How do I break that down? How do I expand it? Well, the first term is always going to be the factorial, n plus 2. What's 1 less than n plus 2? Think about it. N plus 1. Jake, what's 1 less than n plus 1? Just n. Why am I going to come to a stop there? Why don't I want to keep going? Because what's on the bottom of my fraction? N factorial. On the top, I have n factorial. I'm multiplying. What can I do with n factorial on the top and n factorial on the bottom, Jake? In fact, this whole mess simplifies to, or you could write n plus 1, n plus 2. Or you could FOIL that out. I'm not sure what I would do. You could go n squared plus 3n plus 2 if you FOILed it out. B. They want me to simplify, which really means, Francesco, get rid of factorials. Get rid of the exclamation point. Okay. It's a fraction. I'm going to expand the bigger one. Think carefully. What's bigger, n minus 2 or n minus 1? N minus 1. A lot of kids, well, the 2 is big. Yeah, it's subtracting. N minus 1. So I'm going to rewrite the n minus 2. And I'm going to start to expand the n minus 1. So I'll get this. N minus 1. What's 1 less than n take away 1? I'll give you a hint. Not n. Oh, what was that, Brendan? I could go further, but I think I'll represent the further with a factorial symbol. Why? What do I have on top? N minus 2 factorial. What do I have on the bottom? N minus 2 factorial. What can I do with those? Cancel. So I get this. On the bottom, I get n minus 1. What am I going to put on the top there? I can't just leave it like that. What technically is left behind? It's invisible, Darian? A 1. Is that okay, Oscar, so far? C. It says simplify. Suggests that I can somehow, Carson, get rid of the factorial symbol. Which one's bigger? I'll give you a hint. The factorial. The factorial is bigger. Okay? I'm going to start to... So if you don't have a factorial, that's going to be smaller. Trust me. So I'll rewrite the bottom. Let's expand n factorial. What is n factorial if I expand it? Okay, there's going to be an n. That's good because I got one on the bottom. Not a factorial, just a plain old n. Let's keep expanding. What's 1 less than n? That's good. Now, look up. If I stopped here, I couldn't cancel because I can't cancel out a factorial with a non-factorial. This is wrong. Don't write this down. I can't do that. So, hey, let's keep expanding this. What's n minus 1 factorial if I keep going? I'll stop there. The n's will cancel. The n minus 1's will cancel. It turns out n factorial divided by n bracket n minus 1, hey, that's the same as just plain old n minus 2 factorial. Okay. I like example 3, I like example 3, I like example 3.
Example 3 going to be on the test?
Absolutely. We can solve equations with factorials in them. Actually, we can't. What we have to do is somehow use this simplifying method to get rid of factorials. We're often going to end up with a quadratic. Have you guys got a quadratic solver on your graphing calculator? Well, good for you. So you ready? Here's how I would algebraically solve this. First thing that I would do is I would drop down the equals and the 42. On the left-hand side, I want to simplify. What's bigger, n or n minus 2? I'm going to break that one down. So I'm going to rewrite the n minus 2 factorial. How can I break down n factorial? How can I expand it? Well, it's going to be n times what? Times n minus 1 times what? Times what? N minus, ooh. You know what? I could expand it further. I'll stop there and I'll just represent the rest of it with my factorial. What is n minus 2 factorial on the top and n minus 2 factorial on the bottom? What can I do with those? So what I really have, my children, is this. N bracket n minus 1 equals 42. Now what? Remember F was fractions. Do you see any fractions? We've taken care of them. E was what, Darian? Expand. So I'm going to go like this. And I'll get n squared minus n equals 42. Hey, what kind of an equation is this? It's a quadratic. How do I know? It's got a squared. Hey, we did quadratics at the beginning of the year in that lesson, that unit 0, that review. How do I solve a quadratic? Before I do anything else, before I quadratic formula, how do I solve a quadratic? I have to make it equal to 0. So I'm going to go like this. N squared minus n minus 42 equals 0. Now, Darian is reaching for his quadratic solver, which I'm okay with, I guess. But these ones, because Darian factorial were restricted to whole numbers, these will also factor. Numbers that multiply to negative 42 and add to negative 1. Remember doing this last year? What are the roots? What are the roots? What would make this bracket work out to 0? Positive 7. what would make this bracket work out to 0? -6. Except we have a problem. Factorials don't work for negatives. Factorials don't work for negatives. So we have to much like when Jake asks a girl for a date. Reject. Reject. Okay? Now, that's the long algebraic way. You do, on your graphing calculators, have a quadratic solver. Have you guys, I've showed you where the quadratic solver is, right? You could check your answer by going to the equation menu. A polynomial, F2, degree 2, and you could have typed, the number in front of the n squared is, A is 1, B is -1, C is -42, and hit solve, and you also get the roots of 7 and -6, but you still, Grayson, will have to know that you have to reject the negative answer. By the way, the reason is, look up, don't write this down. -6 factorial is undefined because that would be -6 times -7 times -8 times -9 times 1 less. Am I ever going to stop? No. We won't get to 3, 2, 1. So negative factorial numbers, not defined. Turn the page. Where is this on your calculator? You ready? Can you all get your graphing calculators out? And you want to go menu and into the run menu where you do your normal math. Okay? And then hit, nope, never mind. Where is it? Option. Regular, so in the run, so you're ready to do regular math, right? You're there? Okay, you all need to be with me, and I'll pause, but you need to be with me. Hit option. And we don't want the list functions, F1. We don't want matrices, F2. We don't want complex, F3. We don't want to do calculations, F4. We don't want to do stats, F5. We actually want to bring in the second menu. So can you hit F6? Okay, so you ready? Look up. Hit you're in the run menu? Okay, option, F6. All of this unit and next unit belongs to the probability menu, F3. So there you're going to see x factorial. You're going to see something that we'll learn later today or next lesson called NPR and NCR. So for now, find 12 factorial by going 12 and then hit F1 and enter. What is 12 times 11 times 10 times? They get big really fast. So anybody that hasn't found it, I'll pause, but you have to be able to find this, and you have to remember how to find this because I won't help you on a test. Can you find 20 factorial? Seriously? So 20 factorial, you're probably getting an answer in scientific notation already, 2.43 times 10 to the 18th. Can you find 50 factorial? Can you find 50 factorial? Where's your calculator? Okay, you're doing it on that one? All right. This is why I went away from the TIs. Give it to him. Who's got the TI? Ready? Every single time, because on the Casios, the factorial button stays. On the TIs, you would go 12. Math. Left arrow. Down arrow, down arrow, down arrow, enter. You've got to hit 5 keystrokes every time. So you ready, Mac? Find 50 factorial. 50 factorial looks like that. Or 50 math. Left arrow, down arrow, down arrow, down arrow, enter.
Couldn't you just hit 4 because it's the fourth option?
I'm making him do it the long way because I'm PO'd that he didn't bring his graphing calculator.
Okay.
Really, I shouldn't have showed him the left arrow. I should have made him go right arrow 4 times, but I didn't. Hey, what's 60 factorial? Does it work? You got an answer for 60 factorial?
Yes.
Do you get an answer for 70 factorial? Do you get an answer for 69 factorial?
Yes.
So unfortunately, your calculator cannot handle anything bigger than 70 because it overloads the memory, which is why some of those simplifying tricks that I gave you, we'll have to just pull them out of our pocket once in a while if we get bigger numbers in there. So use your factorial key very quickly. What's 6 factorial? I think it's 720. Double check me.
Yep.
9 factorial I don't have memorized. 5040 is a guess. No, that's wrong. What's 9 factorial?
362,880.
362, what? 88? 0. Okay. What if you want to evaluate a factorial fraction? Okay, you can do that. You'll go like this. 10 factorial on the top. Is there more than one number on the bottom? Then those of you in my physics classes, if there's more than one number on the bottom, what does that mean? So we're going to go divided by bracket. 7 factorial, and I think you have to go times 3 factorial. I think if you just go 7 exclamation, 3 exclamation, you get an error without the times sign. You can try it. 120. Let me see if it does.
Yeah, you do get an error.
You get an error, right? Divided by, so that won't work. Get a syntax error. It's saying, put a times sign between them, please. Okay. So what is 10 factorial divided by 7 factorial, 3 factorial? 120. On your own right now, try example 4A and 4B. I'm going to freeze the screen. Let's see if we get to the same location. Max, you're going to be doing a lot more Mac, you're going to be doing a lot more typing than me. I don't know where the X came from. Mac, you're going to be doing a lot more typing than me.
Calculate the value of 43 factorial.
Example 4. Oh.
I'm not too sure what's wrong with my calculator.
Hang on, let me check.
Okay. Okay.
I got 74,046 and 66,045. Is that right?
Yes.
76046 and 66. Can you guys stop with the coins? That's a little annoying and irritating and loud. And 66045. Okay. Now, the point of all of this. It turns out the question that Darian opened the class with, the book question, which was 6 times 5 times 4 times 3 times 2 times 1, I could have just, now that I know it, gone 6 factorial. Factorials are great shortcuts for the fundamental counting principle. So, permutations. We're going to go a little bit longer, and then I'm going to assign 1 through 6. We're going to finish this lesson off on Wednesday. So, permutations. Supposing an internet site's access code is 3 digits. Okay? If you knew the 3 digits, that would still not be enough because they have to be entered in the correct order. The order of the arrangements is important. Underline that, please, for a reason. So suppose John has forgotten his access code, but he remembers that he used the digits 3, 5, and 7. How many different codes are possible? Well, in my Scrabble bag, I have 3, 5, and 7. I can actually use the fundamental counting principle. How many choices do I have from my Scrabble bag for the first digit? Once I've used one of them up, how many choices do I have for the second digit? How many choices do I have for the third digit? What's a much shorter way to write 3 times 2 times 1? 3 factorial. Now, for 3 factorial, Mackenzie, that's not a great shortcut. But for 19 factorial, if you had 19 digits, oh yeah, that's a way better than writing out 19 times 18 times 17 times. That's great. In your head, without a calculator, 6. A situation like this, where the order of the arrangement matters, makes a difference. We call this a permutation. Here is the official definition. A permutation is an arrangement of a set of elements in which the order of the elements matters, is important. In fact, Logan, one of my trigger words is the word arrangement. If I see the word arranged or arrangement, I know it's a permutation. On a test, if I say, or actually the question was, how many different ways can the books be arranged? As soon as I saw that in my mind, I was going, I can do this with factorials and permutations. Okay? As a basic question, in this class, there are 32 students. Don't write this down. How many different seating plans can I have? Does the order of a seating plan matter? Is Mac, then Zach different from Zach, then Mac? Yeah. You know how many seating plans I can have in this class? Which is what? Which is what? So those of you that have had me before in grade 11 and grade 10, you'll know that in grade 11 and grade 10, I randomize the seating plans. I will never use up all the possibilities ever, because there's that many different ways to randomize a seating plan, because a seating plan is an arrangement. Sorry, I can't hear you?
Even if you were to randomize it for every second of every,
Yeah.
second, it would
Oh,
still not be
permutations get big very fast. A classic permutation question is how many different games of chess are possible, and it's long since been shown the number of games of chess are more than the number of atoms in the universe, by a long shot, by a long shot. Okay? Permutations get really, I told you, we're going to count without counting, because to actually physically count them, oh, thank you. Turn the page if you haven't already, or next page over. Ready? Permutations of n different elements taken n at a time. Say what? How many ways can you arrange 5 elements if you're taking all 5 of them? How many ways can you arrange 12 elements if you're taking all 12? And by elements, books, students, how many, answer keys, how many different arrangements? Well, it says list all the arrangements of the letters of the word cat. I don't want to list them. How many letters are there? How many choices do I have for the first letter? Then, you know what? It's that. This gives us, put a star next to this, I'll highlight it. Our general rule, which Darian led us to at the beginning, if you're picking 10 objects and you're rearranging them, you have 10 factorial ways to rearrange them. If you're picking 6 books and you're rearranging them on a shelf, there's 6 factorial ways. If you're picking n objects, there's n factorial ways to rearrange them. So, how many different ways? By the way, one of our fallbacks is going to be words, because I can turn, with a bit of cleverness, many questions into a word. How many different permutations are there of the letters of the word Regina? How many letters are there? Am I picking all of them? Yep. So it's going to be, which is what? 720. How many different permutations are there of the word Kelowna? It is 5,040. Is that what you guys said? I've got, just out of laziness, because we used to use the TIs, and as Mac is finding out, to hit that factorial button every time takes a while. Most of my kids ended up memorizing one factorial is 1, 2 factorial is 2 times 2, 3 factorial is 6. But most of us memorized 4, 5, 6, and 7 because they were the most common, and we got tired of our fingers bleeding from all the buttons we were hitting. One of the reasons I like the Casios that we're using, one of the main reasons I insisted when you brought your TI was for this, to get these accessible easily. Trust me. What if you're not taking all of them? What if you have 10 objects, but you only want to pick 4 of them? What if you have 12 objects, but you only want to pick 3 of them? Or hey, what if you have n objects, but you only want to take r of them? Says, use the fundamental counting principle to determine how many 3-letter arrangement. How many letters? Draw 3 blanks. Can be made from the word graphite. How many choices do I have for the first letter? Then? Ooh, hey, look up. Remember, this is actually, which is way easier to type than 8 times 7 times 6 sometimes. Right? The 5, the 4, the 3, the 2, and the 1 would cancel. In fact, this is so important. Your calculator has this built in. If I am taking 8 objects and I'm permutating them 3 at a time, we write it like that. And on your calculator, it's NPR, which, hey, is right here. If I go 8, F2, 3, that will go 8 times 7 times 6. 336. Okay? So, hey, Mr. Dueck, how many kids are at each desk in my class? How many kids are at each table in my class? How many ways can I rearrange 32 students if I pick them 2 at a time? 32, permutate 2 at a time. Okay. You may end up in a different order, but just sitting next to people, now there's that same person, now there's 992 different arrangements, far fewer than my much larger number. Okay. This is an example of the general rule. Ta-dam! The number of permutations of n different elements. If you're not taking all of them, but Kyle, you only want to pick r at a time, it's NPR. And as a formula, it's n factorial divided by n minus r factorial. Say what? Look up, Rachel. It's 8 factorial divided by, what's 8 take away 3 in your head, Rachel? That's where the 5 came from. That's where the 5 came from. It's n factorial divided by n minus r factorial. It says use this to evaluate. We already did. Oh, I almost want to get through the lesson. Let's see here. 20 minutes left. Ay, 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 ay. Well, let's keep going for a bit here. You make it, Matt? By the way, this is why first of all, can you all on your calculator, can you go 0 factorial? What do you get?
1.
Now this doesn't make sense because if you're supposed to go down by 1, wouldn't you 0 minus, it's your calculator in math, it's programmed, it's defined that way and it has to be. How come? Well, suppose you're taking 5 objects 5 at a time. There's 2 ways to do that. You could go 5 times 4 times 3 times 2 times 1. But if I use this formula here, I would have 5 factorial all over 5 minus 5 factorial, the NPR formula. What's 5 take away 5 in the bottom? we define this as 1 so that this 5 factorial works out to that 5 factorial. Otherwise, we'd have a problem. Okay? So 0 factorial is defined to have a value of 1. Has to be. Otherwise, we'd have a problem. Okay, let's finish off the lesson. I didn't think I'd get through all of it today, but we will. In a region, vehicle license plates consist of 2 different letters followed by 4 different digits. If the letters I, O, Y, and Z are not used, how many different license plates are possible by the fundamental counting principle or permutations? Okay. Fundamental counting principle looks like it's going to be 2 different letters, 4 different digits. How many choices do I have for the first letter, not 26? 22? And the letters have to be different, so how many choices do I have for the second letter now? 21. How many choices do I have for the first digit? Are there any restrictions mentioned in the question? So how many choices do I have for the first digit? 10? Then? 9? Then? Then? Okay, crunch that by hand, please. Can you go 22 times 21 times 10 times? Well, I'm going to do it here. 22 times 21 times 10 times 9 times 8 times 7. And I get 232, 8480. Which works. Or I could have used permutations. How many choices do I have for letters if I remove the first 4 letters that they mention? How many letters are left in my Scrabble bag? Permutate. How many of them am I picking? 2. And how many digits are there? 10. Permutate. How many am I picking? Try typing that in. I bet you get the same answer. Do you?
Yep.
Which one's better? Well, Oscar, the right-hand one is shorter. To me, the left-hand one is easier. It's my fallback. If I come to a yucky question, I fall back on the fundamental counting principle because I'm good at drawing a blank. And you can make whatever joke you want to make there, but I can break them down pretty good. Often what I'll do afterwards is I'll see, I wonder if the shortcut would have worked. Hey, yeah, it would have. And I'll remember that I could use it for that one. What's your homework? I'm going to throw a lot at you. I'm going to give you about 15 minutes on Wednesday to work on some of this too. Okay? 1C. 1C. You can't do that on your calculator. 99 factorial will cause it to crash. So you have to think about how does it simplify. 3. 4C, 4D. 5. Boy, some of these are nasty. I'm going to assign 6, and I suspect I'm going to have to go over it because they've gone tougher than... 6A is one like I did with you, but 6B and C and D are nastier. So if you can't get those, I won't freak out. Then let's talk about arrangements. 7 all. 8 all. 10, you can use any method you want. You can use the fundamental counting principle, or you can use permutation notation. As an example, if I'm only picking 2 letters, to draw 2 blanks to me is faster than finding the NPR button on my calculator. However, if I'm picking 9 letters, I'll probably use a permutation because I don't want to draw that many blanks. So 10, it says do both, use either method, but get the right answer. 11, meh. I skipped 11. 12. I'll pause there. Okay.